Welcome to This Explainer. If you spend any amount of time in a laboratory, you already know it's a space of incredible discovery. But let's be real, it's also a space filled with invisible hazards, volatile chemicals, and biological risks. So today, we're taking foundational good laboratory practices and turning them into your ultimate lab survival guide. We aren't just rattling off a dry list of rules, we're literally looking at the architecture of a safe scientific environment. Let's dive straight in. Now, this right here really sets the stakes for us. We're talking about life-saving habits. It is so incredibly easy to get complacent when you're doing the exact same extractions or titrations day in and day out. But the guidelines we're unpacking today, they exist because somebody, somewhere, learned these lessons the really hard way. Just a single unlabeled beaker, a tiny hairline crack in a glass tube, or even just a split second of distraction can absolutely derail an experiment, or worse, cause some serious physical harm.
So here is our survival roadmap for today. First, we'll cover essential lab safety basics. 2, handling chemicals and acids. 3, managing bacterial culture safely. And 4, decontamination and safe disposal. Okay, let's jump right into this first zone, essential lab safety basics, building your defenses. Think of these ground rules as your frontline defenses before you even pick up a pipette. The contrast between protecting your experiment and totally sabotaging it usually comes down to the tiniest details. Take your gloves, for instance. Checking them for pinholes prior to use, that's a mandatory first step. I mean, literally, a tiny pinhole can cause a disaster. When you move over to the centrifuge, you've got to inspect the inside of the tubes for rough walls or any adhering matter, and never, ever fill a tube to the point where the rim gets wet with culture. On the flip side, don't ever interchange bottle caps. Always put the exact same cap back on tightly to prevent cross-contamination. And, of course, no smoking, eating, or drinking in the lab. That's a strict absolute no. So, as we move past those absolute basics, we really have to ask ourselves, how do we handle threats that disguise themselves as harmless? You see, the most dangerous things in the lab rarely glow bright green or emit ominous smoke like in the movies. Usually, they look completely benign. Which leads us perfectly into our second zone, handling chemicals and acids, also known as the liquid minefield. Entering this liquid minefield means realizing you can never, ever trust your own eyes. Take hydrofluoric acid, or HF, for example. It can look exactly like a harmless little puddle of spilled water. Seriously, that is exactly why universal caution is mandatory. If you see a clear liquid sitting on the bench, your baseline assumption absolutely must be that it is highly corrosive. This is why we physically separate our storage areas for acids, bases, solvents, wet chemicals, and dry chemicals. Getting organized isn't just about keeping things tidy. It literally prevents deadly mix-ups. Now, about those gloves, you can never rely solely on them as some sort of invincible shield to just dip your hand into chemicals. Don't do it! Another surprising but highly logical rule, you must never store chemical containers, whether they're completely empty or full, at a height of more than 3 feet above the floor level. Storing heavy, dangerous stuff above your waist is just asking for trouble. Also, even if you faithfully wore your gloves all day long, you absolutely have to wash your hands before leaving to eat. And here's a fundamental survival rule. Never work alone when handling dangerous chemicals. You always need someone watching your back. But hey, what if the worst actually happens? If a chemical spills on you, do not hesitate. Don't wait for the pain to start. Human nature makes us want to pause and think, wait, did that actually get on my skin? Is this going to burn? The protocol here is crystal clear. Do not wait to see if it gives you a burn. You hit that safety shower or eye wash basin immediately. You rinse for a full 15 to 20 minutes. You report to a doctor, and crucially, alert your team so they can help rinse you off and manage the spills safely, because honestly, seconds matter here. Okay, if you only remember one golden rule from this entire explainer today, make it the 3 A's. Always add acid. Never the other way around. If you pour water into concentrated acid, the sudden heat generated can actually cause the liquid to violently boil and splash right back in your face. So, always add acid to water or a base, and do it slowly. Oh, and never store acids and solvents together, and definitely don't mix them. Pouring solvents down a sink with acids can trigger a massive, violent reaction. All right, so having conquered the chemical zone, we now have to figure out how our survival tactics shift when the hazards are actually alive. Chemicals behave predictably, right? They follow the laws of physics and chemistry. Biological cultures, though, that's a completely different beast. They replicate, they can go airborne, and they demand an entirely different mindset. Let's step into our third zone,
managing bacterial cultures safely in the biohazard zone.
We are now in heavily restricted territory with live cultures and invisible airborne risks. It sounds like absolute common sense today, but you must never, ever mouth pipette bacterial solutions. Doing that actively aerosolizes infectious material directly into the air you are breathing. Always use a pipetter. Your work area for live cultures must be completely restricted from general use, and you should only be handling them inside a laminar flow chamber. Remember, these are invisible threats. Creating sprays or aerosols by forcefully blowing material out of a pipette or bubbling expiratory air through the liquid, that is strictly forbidden.
So, what happens if a bacterial strain hits the floor? First rule, you don't panic. You follow this exact 3-step decontamination protocol. Now, inside a laminar flow chamber, sure, you can use ethanol or spirit to disinfect. But for a floor spillage, you pour sodium hypochlorite solution, good old bleach, directly onto the spill. And here is the kicker. You do not wipe it up immediately. You wait a full 15 minutes. That waiting period is absolutely non-negotiable to ensure the biological agents are actually destroyed. Only then do you wipe off the area with cotton, while wearing your gloves, of course. Okay, so we've handled the materials safely on the bench, but now we face the final hurdle. How do we safely erase the dangerous footprint of our experiments so they don't harm the environment, the public, or the sanitation workers down the line?
That brings us to our final section, decontamination and safe disposal, the cleanup phase.
When it comes to exit strategies, you can't just toss things in the trash. Every single substance has a highly specific neutralization path. You absolutely cannot pour concentrated acids down the drain. You have to dilute them first. For general chemicals, you must verify they are actually compatible with the drain material before dumping them. Godicidium bromide, or ETBr, that's a known dangerous substance. Its solutions must be treated with activated carbon, charcoal, to remove the ETBr before draining. And related materials actually need to be exposed to the sun before final disposal. And biologicals, things like agrobacterium strains or transgenic plants, they go into polythene bags, get explicitly sealed with red sellotape, placed in a biohazard dustbin, and then they must be autoclaved by the right personnel to completely sterilize them. And every single step of this gets documented in a maintained register. So, I'm going to leave you with this final critical thought to reflect on as you button up your lab coat tomorrow. Are your daily lab habits protecting your team, or are they putting everyone at risk? As we've seen today, good laboratory practices aren't just bureaucratic red tape. They are highly specific, deeply logical defenses against the liquid minefields and biological risks of the scientific frontier. Whether it's taking 2 seconds to check for pinholes in your gloves, remembering to always add acid to water, or respecting that non-negotiable 15-minute bleach protocol, your actions dictate everyone's safety. Stay focused, stay vigilant, and respect the science. Thanks so much for joining me on this explainer.